All right, so it was requested that I work through some of the circular basic practice questions. 7 and 9 specifically were requested. Since those kind of build on prior questions, I'm going to work through questions 6 through 9. If you have any additional questions you'd like to see, please let me know. So let's start with number 6. Number 6 says, a record player moves with an angular speed of 45 revolutions per minute. What is the angular speed of the record in radians per second? All right, so the first thing we need to do to analyze this question appropriately is we need to look at what a revolution is. So for number 6, we need to say 1 revolution is equal to 2 pi radians. What that means is that every time it goes around in a circle, makes 1 complete revolution, the linear distance that has been traveled is 2 times pi times the radius of that circle. So if you were to take a point on the edge of a circle and figure out how far it was from its radius and watch it go around one circle, multiply it by that radius, 2 pi times that would be the linear distance or the circumference of that circle. So next, we know from the problem that it is moving with an angular speed of 45 revolutions per minute. 45 revolutions in 1 minute. So now it just becomes a matter of doing a little dimensional analysis. So if we know this answer is in minutes, and we want our answer in the base unit for angular motion, which is radians per second, we've got to get rid of minutes. So let's take care of that first. 1 minute is equal to 60 seconds. 1 minute is equal to 60 seconds. That's the same thing on the top and the bottom, and if you have something divided by the same thing, you get the answer of 1. Which means if I multiply this by 1, I don't change my answer, but I change my units. So I can get rid of minutes. Now I've got 45 revolutions in 60 seconds. Not there yet. I don't want revolutions, I want this in radians per second. So I've got to do one more step, and we know from this equality up here that 2 pi radians is equivalent to 1 revolution. Now, revolutions on the top and the bottom, those will get canceled out. 45 times 1 times 2 times pi divided by 1 times 60 times 1, which is just 60, will give me an answer in radians per second. So the answer for this question, if you multiply all that out, should be 4.71 radians per second. Number 7 builds on this question. Number 7 says, if the radius of the record in the previous question is 1.2 centimeters, what is the linear speed at the edge of the record? So I'm going to call your attention up to some of the equations we have up here at the top. And these equations up here say that angular velocity is equal to translational velocity divided by r. Angular acceleration is equal to translational acceleration divided by r. What that means is if you take the linear quantity and divide it by the radius, you get the angular quantity. Linear quantity divided by radius gives you the angular quantity. Well, here in this question, we have the angular quantity, and we're trying to get the linear quality, our linear equation, our linear answer. So for number 7, we start with 4.71 radians in 1 second. That is radians per second, that's alpha, and the question, number 7, says what is the linear speed? Okay, so what we have to do is multiply what a radian is, and we can get radians out of this and get meters per second. So we know, let's see, the radius is 0.012 meters. All I've done is taken 1.2 centimeters, converted that to meters, and that is equal to 1 radius. Hey, look, now radians cancels with radius. 4.71 times 0.012 should give me the correct answer of 0.056 something something meters per second. Number 8. Number 8 says, a bicycle wheel is accelerated from rest to an angular velocity of 2.4 radians per second in 0.6 seconds. What is the angular acceleration of the wheel? Well, if we were dealing with linear acceleration is equal to delta v divided by t, change in velocity over time. Delta v is final velocity minus initial velocity. Well, the same thing is true for angular acceleration. So instead of this, we're going to look at alpha. Alpha, angular acceleration, is equal to delta omega, which is the same thing as final angular velocity minus initial angular velocity divided by time. Our final angular velocity is given in the problem. It goes from rest to 2.4 radians per second. 2.4 radians per second. Goes from rest. Its initial angular velocity is 0 radians per second, divided by the time, 0.6 seconds. 2.4 minus 0 is 2.4, divided by 0.6 equals 4 radians per second. Wait a minute, seconds divided by seconds, that's seconds squared. Okay, so now you have an angular acceleration converted from that information. Number 9. Number 9 says, if the radius of the bicycle wheel in the previous question is 25 centimeters, what is the linear acceleration of the wheel? Well, we've done a problem that's sort of like this. We know that anytime we have angular acceleration, it is equal to translational or linear acceleration divided by the radius. Alpha is equal to a sub t divided by r. So we can use that for number 9. For number 9, that tells us that a t, the translational or linear acceleration, is equal to alpha times the radius. We just solved for alpha in the previous problem. So all we have to do is multiply 4 radians per second by the radius. The radius was given in the problem, 25 centimeters, must use meters, 0.25 meters. Okay, so if we multiply that by this quantity, 4 times 0.25, we get, oops, sorry, that's squared, can't forget that. So the radius, that is 1 radius. Radians cancel. 4 times 0.25 equals 1 meter per second squared. That's it. If you guys have any other questions, you are welcome to answer or ask them, and I'll do my best to solve them in a way that's helpful. Hopefully this helps, and just keep in touch and let me know what you need.